There are many ways of visualizing data, and the most appropriate way to visualize data tends to be topic specific. However, I do want to say a few words about when to use different kinds of visualizations. First up is line plots. Line plots are often used to show how something changes over time or over space or across different groups. The main thing to keep in mind about line plots is that you are making an assumption with line plots that you know what the values would be at the data points between the time points that you've actually measured. So for example, in this line plot, each of these squares here corresponds to an actual measured data point, and these lines are just drawn between them. Now, by drawing these lines, you are making the assumption that, for example, the data value at this point here corresponds to this y-axis value. But this is really just a guess if you don't actually have any measured data at this point. Sometimes line plots are used when they shouldn't be. Here you see an example. This is a plot showing the number of people with a certain name in some class. Now there's nothing wrong with these boxes per se, those are fine, but the lines drawn in between them are in this case a little bit awkward because you're making an assumption that if you would measure in between Muhammad and Mary, you would get, 6 individuals, a count of 6. But that doesn't make any sense because these different names are discrete. There's no smooth transition between John and Muhammad, for example. So make sure that when you're using line plots, it is reasonable to assume that there could be data in between these 2 points, even if you haven't measured data there. Next, I want to talk about bar plots. Bar plots are quite common, and they are often clear and easy to read. The main thing to think about with bar plots, or really any kind of plots, is to use appropriate axis ranges. The point is not to show the bar, the point is to show the differences between the groups of bars. So this bar plot shows exactly the same data as this bar plot, but zoomed out on the y-axis. And so the differences between the bars, which are visible here, are tiny and barely noticeable in this plot. And now this bar chart shows again exactly the same data, but zoomed in. And now you can really see the differences between the different groups. Color in bar plots can also be a really useful way to highlight the different sets of bars or the differences between the bars, and I'll talk about color in later videos. Dot plots, or often called scatter plots, are used to show a relationship between 2 variables. Those 2 variables should have a lot of values, and there should be a meaningful relationship across the different values. For example, if you have data on the number of car accidents as a function of speed limit, then a scatter plot makes sense. Now here I have no data for a speed limit of 58 miles per hour, for example, but it is reasonable to assume in this case that if there were data points with a speed limit of 58 miles an hour, those data points would probably lie somewhere around here. And that's because there is a meaningful relationship between the points on the x-axis and the points on the y-axis. Next we get to pie charts. Pie charts are used to indicate proportions or fractions of a whole. Pie charts only really make sense if you're displaying something that sums up to 100%, or when it makes sense to sum it up to a total. And that's because when people look at a pie chart, they interpret it as a kind of zero-sum game in which more of one category necessarily means less of some other number of categories. As I mentioned in the beginning of this video, there are dozens of ways of visualizing data, and many ways are specific to whatever topic you're focusing on. The important thing is not to just use any random type of visualization because you saw it somewhere else and you think it looks cool. Instead, you should first think about the data, think about the main message, and then figure out what is the best way to visualize those data.